With that background, you see what exactly is the role of machine learning. We talked about machine learning as a way by which you define any kind of history of performing some tasks. Then you define there's a metric by which you measure performance of how you're performing a task. It can be human, it can be an agent, it can be a software program. Then it is set to learn from experience if that metric on which you define the performance improves. That is very important. So basic idea, there are three elements here. One is you need to have experience data, which is historical data of how things have been happening. You need to have the task definition of the task at hand. Then you need to define a performance metric. What is the metric you want to do? So at this point, we also want to talk about, like, when we look at different kind of use cases, there are various domains like manufacturing, high tech, where robots use machine learning to define the ideal path, or they define different ways of avoiding obstacles in the way. Autonomous vehicles, you're aware of the Google car, which actually uses a combination of computer vision and does machine learning algorithms on the way flight to decide optimal way or way to avoid obstacles or to follow traffic rules, etc. Speech recognition, I already told you how it is used in the context of voice, BPO, and automation. Language recognition is very important if you want to do machine translation from one language to another. There it becomes a very important element due to of a approach where you start input in one language and end up in another language. Google Translate is a great example. So machine translation actually uses a whole bunch of machine learning algorithms behind the back, built upon corpus from linguistic experts. Then we talked about recommendation systems, which is very important from the context of online commerce. I'm sure all of you are aware of the Amazon, where you start browsing something based on your historical purchase, you're given very close to your interest in item which is thrown back to you. Same thing in Google search engine. All of these are basically using something known as recommendation systems, which are basically based on underlying acquisition rule mining or some kind of a diagnostic system. In healthcare, diagnostics is about very important thing. Like diagnostics is about relating most possible cause having observed an effect. You may observe that you are feeling sick with high temperature, with high fever, running nose. So the diagnostics will try to identify a most probable cause. You may start with a simple thing like a common cold, but it may go on till even maybe do you have malaria, or do you have some specific thing like a typhoid, or even H1N1 flu. So the idea of diagnostics is very important in healthcare. In manufacturing, it's about understanding if there's a defect. What is the root cause of the defect? Where did the failure happen? What is the root cause of some fault happening in the machine? Then we talked about fraud detection, which is very important on banking transactions. Look at all the historical transactions, see if there are specific anomalies in the way some specific access has been not behaving as per the predicted nice behavior of a service access. That gives you a hint into it has been hacked or somebody has stolen some identity or something like that. In insurance, it's very important to detect if something has done willfully or if the incident happened and it's real. They use all kinds of machine learning to correlate actual happenings with claims that are being put in. In terms of computer vision, that is actually the powering technology for robots in order for them to understand objects, identifying, learning from that, creating alternative paths, and maybe even reaching a goal. And the last one which we talked about, which is very important, was from BPO perspective and IT management, remote infrastructure management perspective. We talked about how machine learning is helping create software programs which can take on some of the very trivial services where human intelligence is not probably overqualified. So we can do simple things like filling up forms with predetermined data by extracting documents from invoices, like purchase orders, etc. Or if there is a workflow which requires data extraction from multiple SAP systems, some web-based systems, and put it into a report, this can be really automated. Or if you're talking about resetting a database and remote infrastructure, these are examples where you can train programs and use them to achieve the underlying task. But what is it we are trying to do here when we're talking about automation? We're actually trying to create a machine which can learn from past experience of what human experts have been doing and try to mimic how they can be done with relatively less human involvement. In some cases, it could be replacing a human, but in several cases, it could be aiding a human in possible decision making. For example, if you're talking about, say, bug fixing in large code bases, we can talk about creating a learning algorithm based on past bug fixes and use that to help a programmer who's maintaining large system as to what is the potential locations where the source of this kind of bug may be happening. So given that typical use cases we talked about is like predicting if a customer transaction is a fraud or in search, which ad is relevant in search or in e-commerce, predicting buying patterns in e-commerce, recognizing people in videos. I'm sure you're all aware of several breakthroughs which happened by Homeland Security and people like that who look at video recordings of airports and then get back with actually taking on people who are responsible for doing these acts. And it is pretty fast. If you look at the kind of alacrity with which they respond, it's based upon large amount of computer vision plus machine learning. Machine learning is about understanding from large databases of biometrics they have, and they use that to identify who are kind of what we call the bad people. Let's look at written text. This is very important. People are talking about translating large old texts into new languages, or even trying to understand summaries of these texts. Then speech recognition is very useful, especially if you're talking about voice-based call center automation. With all recent mega projects done by Google, Microsoft, etc., where they're talking about being able to recognize an animal or a picture in large collection of YouTube videos without any human involvement. So same thing happens in case of ImageNet, which is a large library of images and where you're asked to do some classification. So another example is robots. Robots is a basic classic example of use case where we talked about being able to recognize an obstacle, trying to find an optimal path, avoiding obstacles in the path, and go over it. Last one is very important is instrumentation plus instrumentation means Internet of Things plus analytics or machine learning is very important for the dementia patients to be instrumented with sensors sending data to some monitoring center and to give them context based on learning from the past experience and give them precise location and precise task where they're stuck. So this is a classic example of where we're using Internet of Things for sensing and using machine learning for sending the appropriate response. So what do you do in these kind of scenarios from the perspective of usage of the right techniques? Let's first identify what